present in my talk some aspects of seed production and a European survey we did within the live seeding project. My name is Karl Vollenweider and I'm an organic breeder at Dottenfelder Biosaat GmbH in Germany. So let me begin with an outline of my talk. I would first like to begin to present our experience with organic heterogeneous material, which we gained at Dottenfelderhof during the past 2 years. And second, I will briefly focus on seed production. And finally, I will give an overview of this European survey on OHM. So on the picture, you see the Dottenfelderhof with on the left-hand side a small part of our breeding nurseries. So let us start with our experience on OHM. So in fact, we have developed OHM for the 3 species, rye, maize, and wheat. On the picture, you see our winter rye, OHM baldachin. And what I would really like to highlight here, what already Ricardo told you, is that the definition of OHM is very broad. So it includes outcrossing species such as rye, as well as self-pollinating species such as wheat, and even clonally propagated species. So we also experiment with other type of crops like peas and oats, but really of these 3 crops we have notified organic heterogeneous material in Germany. And in total we have 7 OHM cultivars. So of these cultivars, of most of them, we sell seeds. And the corresponding area under cultivation of our OHM crops is almost 400 hectares in 2022. So most of this area is covered with the winter wheat, OHM, Brandex, and Leo Charles. You see a picture of Leo Charles on the left with its colorful ears and awned as well as unawned ears. And from these 2, we sell seeds which are grown on more than 250 hectares. So for our standards, that is, all of this is around 10% of our total seed sales. And for our standards, these winter wheat OHM are quite popular with farmers, and for the following reason. So I will present some results of field trials which we conducted at 4 locations in Germany and Switzerland in 2019 and 2020. So in the trials, we included some pure line varieties, which are the orange dots, and the rest, the blue dots, are OHM or populations. So now let's look at the data. So on the y-axis, we have grain yield in decitons per hectare. So the trial average was 45 decitons per hectare, which is a good organic average. But we look here at really bred wheat OHM and bred wheat varieties. So we also have to look at some baking quality parameters. And here I have drawn the wet gluten content in percent. This is a measure of how much gluten is contained in the flour after other components such as starch are washed out. And a value of above 25% in our region is considered as a high gluten content for organic bread making, and farmers usually get a premium above this threshold of 25%. So what we see in the picture, in the graphic, is that Brandex and Leo Charles have the highest grain yield, but still a comparable wet gluten content to the average of the varieties. And importantly, it is well above this 25% on average, which is really what we want. So what is special about our OHM is that it is well balanced with respect to these 2 parameters, grain yield and wet gluten content, which is important in practice. In other extensive field trials, we could additionally show that the stability of baking quality parameters was actually higher of OHM than of the reference varieties. So that is also how our populations were developed during breeding. And that was done very similar to what Anders Borgen just presented. So what we did is we mixed up breeding lines with different strengths and weaknesses in order to get such a balanced OHM. And that is what we called, borrowing a term from the previous projects, we would call this dynamic breeders populations. And these are really generated from breeding lines, but then after this, they are managed as bulk populations. So sown and resown by breeders and later farmers. We will see this. And what I would like to stress is that human selection is allowed in OHM development, especially also in early development stages. And as we have seen in previous presentations, there is a full spectrum of OHM beyond CCPs. So in the legal text, just a mixture of registered varieties is not organic heterogeneous material. But we would argue that already a mixture of breeding lines, which are then kept as a bulk, is actually OHM. And of course, composite cross populations are OHM, but there is a full spectrum in between. So you could think about taking breeding bulks as starting point of OHM, or lines in very different generations in your breeding program and mix them or cross them. And this spectrum really should be explored. So what we should emphasize is that there are still defining characteristics of organic heterogeneous material. Actually, according to the delegated regulation, it has to have a high genetic diversity, which means in the legal text it is written that it shouldn't be possible to represent it by a small number of individuals. So I would argue that for self-pollinating crops such as wheat, this means that you have to mix, I would say, at around 10 lines at least. And second, organic heterogeneous material has to be characterized by its dynamic nature and its ability to evolve to different growing conditions. And this we do with our wheat populations because we really manage them as bulk populations. So I guess we are there also on the safe side. And now let me mention a few aspects on seed production as promised. So the organic heterogeneous material of Dottenfelderhof is multiplied, as I said, as bulk populations. And this is actually done at 1 or 2, maximum 2 farms. And we don't yet involve more complex schemes like dynamic management, which was suggested by Henri and others, where you really keep this OHM at several farms and you exchange seed between these farms in order to keep the full diversity of the OHM, or you keep more diversity, you stabilize the diversity more than we do by just keeping it one population. But for practical reasons, this has to be really considered as a future option because we don't need so much seed yet. And what is important, that farmers are quite keen to save seeds of our OHM. So there we have to be careful in the communication and really tell them how important seed cleaning is. And as Anders said, breeding has to be financed. Still, we practice a very open system. So we just sell the seeds, and after this, we ask farmers for donation. So our seed distributors who bought seeds and tell them, in case they do seed saving, please give the breeders a donation. And that's how we finance now our OHM breeding. In general, with our seed multipliers, we try to handle OHM as similar as possible to varieties, also in order for them to make it easier, all the handling. Since our quantities are quite high, we try also to do, we do always seed analysis, and we have field inspections of our OHM fields. And this is important for us. It might be not so important for other actors, such as if you are a very small actor or conservation, due to conservation of genetic resources. That's not what you want, but for us, we do this. And again, as in the case of seed saving, we have to be quite careful with seed-borne diseases, because in OHM you can have new types which may not have your resistance, and you also have to be a little bit careful with seed cleaning, because that's especially true for this dynamic breeders population, where you have still quite a few lines. And so you have to be careful with the seed size. That's what we realize. Otherwise, you change the composition of the population. But apart from this, we are very happy with our system. So we have a company, it's called ÖMKi Hessen. It's a collaboration of 6 farmers in our federal state in Germany. And they sell all these seeds of our OHM, as we have seen. And that's a cleaning machine on the picture of this company. So finally, let me give a very quick overview of this European survey we did on organic heterogeneous material. So on the slide, I have just tried to collect the information about the notified organic heterogeneous material. And as we have seen, there are 2 officially notified wheat populations in Denmark. And in the very last column, you see the cultivation area, which is more than 400 or 500 hectares in Denmark. And in Germany, we actually have 13 organic heterogeneous material of these 4 species on the slide, so wheat, maize, rye, and faba bean. And also, if we add it up, it's surely more than 400 hectares, but we still have to improve the quality of the data. It may be more than 500 or 600. And in other European countries, there is actually notified vegetable organic heterogeneous material from the Czech Republic. There seems to be also organic heterogeneous material in Slovenia, but this table should really be considered as work in progress. So there are other countries. We have a much more sophisticated table in the live seeding project, where we also include material in the development phase, and especially material which is in the testing phase, so where there are field trials performed. And that's also why we are here, to share our experience, to learn what organic heterogeneous material there is in Europe, and to discuss the different issues. So thank you very much for your attention, and I look forward to the discussion. Thanks very much.
Thank you very much, Karl.